All right, Thursday, 5:30. Welcome to one of the last sessions for reInvent today. This session, don't want to tap the mic. This session is end user computing on AWS with Amazon WorkSpaces and Amazon AppStream 2.0. I'm Jeff Ferris. I'm a desktop and application streaming specialized solutions architect. That is a really long title. You have to fold my business cards twice. I'm based out of Austin, Texas. Been with Amazon for about 4 years. So we're going to cover today a brief overview of Amazon WorkSpaces, an overview of AppStream 2.0. Then we'll go into considerations for Active Directory integration, account setup, network configuration for an enterprise use case. We'll talk about creating access to corporate resources from both of these services. Then we're going to wrap it up with a demo, hopefully. So we already know you're an AWS customer. You're comfortable probably with the traditional workloads for AWS, the web applications, database hosting, file servers, and so on and so forth. You can get a lot of the same benefits with end user computing on AWS. With WorkSpaces and AppStream 2.0, you can develop a single desktop application delivery strategy that can provide access to your applications and flexible desktops that are available for your end users anywhere on any device. So as IT, you're worried about end user strategy. You're hopefully designing strategies that can enable multiple platforms and devices, enable bring your own device solutions while remaining secure, performant, and available. And with AWS, we'll allow you to do all of that with controlled costs and familiar interfaces for management. So as I go into some of the details for the individual services, I'll drill down on what we do for security around those different solutions, how we give you the performance of the AWS cloud. One of the interesting things about both solutions is that each user has an instance for each of the services behind whatever they're accessing. So you get that consistent performance at scale, regardless of how many users you're adding to your environment. WorkSpaces is available in 8 regions: Virginia, Oregon, Ireland, Frankfurt, London, Singapore, Sydney, and Tokyo. AppStream 2.0 is available in 4 regions: Virginia, Oregon, Ireland, and Tokyo. So that gives you the ability to easily spin up those services in new regions in response to business needs, mergers and acquisitions, employee global moves, and things like that. All right, we're going to start with the overview on WorkSpaces. So WorkSpaces has been around a little bit longer. I'm not going to spend as much time there as I will on AppStream. So WorkSpaces are really the managed cloud desktop solutions, right? Desktop as a service. It's a pay-as-you-go model. With WorkSpaces, we have 2 different options. There's a monthly purchase option if you're really looking at a desktop replacement approach, and then there's an hourly option for users who don't need full-time access. Something to know about that is the break-even point tends to be around 82 hours, depending on the instance size that you're using, the bundle size that you're using for WorkSpaces. So even for part-time users, if they're doing more than 82 hours, it may be more cost-effective to use the always-on bundle types, the always-on workspace types for that solution. And we do offer a WorkSpaces cost optimizer that will monitor your environment and help make recommendations on usage patterns that it sees for WorkSpaces and guide you into which ones may be better suited as hourly versus monthly. And we can also set that service to automatically convert your WorkSpaces for you. It's a couple of Lambda scripts that run in your account. You can find that in the AWS Solutions Builder website. WorkSpaces is built on a secure platform, so end-to-end encryption. Initial authentication to the service is through SSL over 443. Once the session is established, it supports AES 256-bit encryption for the streaming session. We stream using Teradici's PC over IP protocol. That's TCP and UDP ports 4172. And that's for the entire session. The web client, WorkSpaces has a web client that will communicate over PC over IP if it's available. If 4172 is not open in your environment, it will fall back to SSL over 443. So to get the highest level of encryption in your WorkSpaces, there is a PCOIP.adm template file that you can import into your group policy management console. You can disable those lower encryption standards. We do support AES 128 and 1 or 2 other encryption standards. If you disable those, it will always fall back to AES 256. Additionally, WorkSpaces are storing data in the cloud. So as far as security goes, you're leaving nothing on an end user device. It's really hard to leave a cloud computer in an airport lounge. So that user data is protected. If that's not enough, we also offer encryption for that local storage, so you can encrypt your data at rest. That'll help you meet audit policies or just increase your security posture in general. The key management services are used for WorkSpaces encryption. You can either use our keys, use your own. This ensures that the EBS volumes that back your workspaces are encrypted. There's a user data volume and a system volume. You can decide whether you want to encrypt both, or one or the other, or you can currently leave neither of them encrypted. And then workspaces, of course, are simple to deploy and manage. There's no infrastructure to design for the streaming gateways. We handle all that heavy lifting for you. The service has a full exposed API, so you can use it with whatever your favorite programming languages. We have SDKs for Java, for PowerShell, for Ruby. A lot of times in the Windows world, you're going to fall back to the PowerShell tools. But if you wanted to integrate it with any other system, we have open APIs to be able to do that. All right, use cases for workspaces. Workspaces really fit almost anywhere where you're currently using a full desktop solution today, right? Anywhere where you have a full Windows desktop. So projects in the end user space tend to take some time, right? If you're changing user behaviors, you're changing things out in significantly, the things that affect end users, it's not going to be a fast rip and replace, right? So when we're talking about use cases, we always recommend starting with something kind of simple and basic and expanding as you see what the product can do and get ideas for other use cases in your environment. We use workspaces, we see a lot of workspaces in training environments. And in fact, if you've been to the SANS, the hands-on labs there, the Spotlight labs, or if you've taken a certification exam this week over at the Mirage, those training environments were fully built on Amazon Workspaces. And at reInvent, they have been for the last 4 years. So as it happens, that's kind of how I came to be a workspaces specialist, but that's a story for another time. So internally, Amazon.com uses workspaces throughout the corporate environment. I haven't had personally, I did it again with a mic. I haven't personally had an Amazon provided piece of hardware, physical asset, since we rolled workspaces out for the corporate users, corporate space about 3 years ago. And I haven't used a VPN connection at Amazon since 2015. Outside of Amazon, Caltech's Gutman Labs use workspaces as a bastion host into some of their high-performance computing environments. Endemol Shine Nederland uses workspaces. They're the producers of Big Brother, American Idol, Biggest Loser. They use workspaces heavily with their temporary workforce, their contractors, their contract video crews. They issue workspaces to those users for the duration of their video projects. And based on their assessment, they've just found that they're saving about 30% on their desktop operating costs and 70% on capital expenditures. The Louisiana Department of Corrections, through Atlo Software, provides access to inmates at correctional facilities to deliver training content in a secured environment. So there's no outbound access from that Workspaces VPC. There's no way for the inmates to get access to content beyond what was offered in the VPC as the intended training materials. So security and compliance, I touched a little bit on it in the prior slide, but as far as compliance goes, we have the SOC 1 to ISO 9001 and 27001 certification. The updated SOC reports are available on aws.amazon.com/compliance. If you have an executed business associate agreement with AWS, you can start using Amazon Workspaces to deploy HIPAA-compliant cloud desktops that access protected health information, PHI. That's a certification we added this year as we added that with PCI as well. So PCI DSS Level 1. Workspaces has been verified to conform to the payment card industry security standards and can be used with applications that contain or access sensitive cardholder data. We're also ready for EU General Data Protection Regulation. GDPR regulations are required, I believe, in March 2018. Workspaces is already ready to go with GDPR regulation requirements. All right. AppStream 2.0. So where Workspaces gives you a complete desktop experience, AppStream 2.0 gives you a set stack of predefined applications that are delivered via a browser. So again, with AppStream 2.0, there's no infrastructure for you to manage. You simply create an image, set some parameters for instance sizing, minimum, desired, and scaling parameters. And the AppStream service provisions and deprovisions instances as necessary. It's a pure usage model. You're paying for resources that are needed by the hour as they're being used. Services are accessed through a browser over HTTPS. It's an SSL encrypted traffic between your end users and the AppStream 2.0 instance that executes your applications. User access can be controlled through 3 different mechanisms: through a custom identity provider, through integrated user pools as a simplified way to manage access. Now that's going to require a unique portal per region if you use the user pool feature. Or for domain joined or non-domain joined instances, you can provide access to the environment through single sign-on using Active Directory and SAML 2.0. If you've used a domain-joined fleet, if you're accessing it with SAML, you can also, because those systems are part of your Windows domain, you can manage them with standard Windows management tools like group policy settings. So group policy settings that you might apply to your user environments can also be applied in the AppStream 2.0 world to create settings, map to printers, map to drives, and things like that. So why did we build AppStream 2.0? AppStream is really an easy way to address some enterprise requirements for application streaming platforms, right? What we heard from customers is there's a lot of desktop applications, common off-the-shelf stuff that maybe they didn't have access to the source code. We wanted to be able to provide access on multiple device types to those applications without a heavy lift, without a lot of heavy customization, or without having to go in and modify those programs. It's expensive. It takes a lot of time, takes a lot of money to rewrite applications as web apps. Users need instant access to applications from anywhere, ideally on any type of device. And as IT, we want simplicity, right? We're kind of lazy. We want to be able to do things the easiest way we can. So we found a way to let you install applications on Windows instances and set up the streams, and the applications, for the most part, just work. There's no code to rewrite, no changes. Just launch an image builder, install your software on Windows using a standard install mechanism, whether that's an executable file, an MSI, file copy. Run the image assistant from within the image builder, and I'll show that in the demo later. You just point to the shortcut, and that makes the application available in the AppStream console. AppStream 2.0 has a network interface in your VPC that allows you to interact with your existing applications, your identity, your entitlement systems, any kind of back-end licensing systems, anything you could otherwise access from within your VPC. And it is one streaming instance per user, so there are no shared instances. We have multiple instance families, so you can really match application workloads to instance characteristics. The general purpose family is meant for knowledge worker type workloads, your standard Office applications, access to intranet sites, things like that. We have compute, memory, and graphics optimized instances that all allow you to split to AppStream instances that focus on those particular parameters. If you have applications that do a lot of in-memory visualization, you might look at a memory optimized instance. Or for graphics processing, for CAD applications, things like that, you can use graphics optimized. Within the graphics families, we have 3 separate families and 8 instance types. So graphics design instances are powered by the AMD FirePro, got to look at my notes here, S7150X2 GPUs. Those are ideal for delivering applications that rely on hardware acceleration of DirectX, OpenGL or OpenCL, such as Adobe Premiere Pro, Autodesk Revit, Siemens NX. Now, if you need CUDA support, our desktop family uses the NVIDIA K520 GPU, and our Graphics Pro uses the NVIDIA Tesla M60 on instance sizes up to 488 gigabytes, gibs. I'm not sure how we shortcut that one. With a graphics memory of 32 gibs. So Graphics Pro instances are ideal for those workloads that need that massive amount of parallel processing power for 3D rendering and visualizations. Video encoding, things that include like Petrel's petroleum exploration and production software from Schlumberger, Landmark's Decision Space for geoscientific analysis, or Motion DSP's Ikena for real-time video enhancement and analysis. Now, I don't know how to use any of those tools, so later I'm just going to use it to render a toy helicopter. So. All right, so building these solutions in the enterprise. Let's get into a use case. So we're going to start with a scenario, an existing AWS customer. You've got a hybrid architecture, a mix of applications in-premises and on the cloud. Using an existing Active Directory environment for identity. We're going to assume Direct Connect is already in place. And we're going to talk about a solution that focuses on about 4,000 users. Now, in this environment, we'll say 30% of that is a contingent workforce, about 1,200 users, and about 10%, 400 users, have needs for those high-performance or GPU-based workloads, something that goes outside of the normal desktop requirement. So the approach, and obviously I'm going to have to generalize and oversimplify things a bit here. User segmentation is going to be different for any organization that you look at. So you really got to think about what that segmentation looks like first, and decide where your initial use cases are going to be. What are your main drivers? Are you looking to completely change your end user environment, and that is simply the driver that you have? Do you have a cloud strategy that mandates everything move to the cloud? So you're looking at a way to move end user workloads there as well. Do you perhaps have concerns with asset management for your temporary workforce? Or engineering workers complaining that they need more powerful systems to support some of their applications? Developers regularly requesting systems that are well outside of the normal specs for what you provide everyone else. So you can use WorkSpaces or AppStream potentially to offer better performance or to simplify the experience for some of your users versus say a VPN solution. These are just some of the elements that can go into your decision-making process. You need to establish that success criteria up front. Is it going to be driven by user acceptance, by cost reduction, by environment simplification? What is your ultimate desired outcome? From the technical aspects, you can certainly do a high-level proof of the technology with standalone systems, but you're really only going to be able to prove out the performance of the protocol in a given user's environment if you haven't given them access to systems that are actually in their environment so that it becomes a part of their regular workload. A key element to moving from a proof of technology to a real proof of concept is that connectivity to those corporate resources, right? From WorkSpaces, you're not going to have an accurate gauge of user acceptance until users can get to their email or can get to their file shares, can print to their regular corporate printers. From AppStream, do you have access to the corporate resources, the intranets or intranet content, whatever internal access things people use every day? It's really that key piece of moving beyond the pure proof of technology. All right, so the first step in any implementation is going to be your account structure. We covered this topic in a lot more detail in last year's Best Practices from the Trenches session, so I recommend catching that on YouTube. It's an exciting session the whole family can enjoy, perhaps over the holidays instead of the Christmas parade. Highlights are here. So some key recommendations. Use a payer and linked account structure. Usually in larger enterprises, I'll recommend putting only logging, configuration, and billing records in the primary payer account. The separate AWS accounts really give you those distinct administrative boundaries. So your end user administrators are usually different from your DBAs, from your application administrators, and that's why you see the end user account as a separate entity on this diagram. But for the other areas, you could separate accounts by type of environment, dev prod, like shown here. You could use business segments. You could use departments, or I've seen some companies that do different accounts based on legacy applications versus cloud optimized applications. It doesn't really matter. The key is you're using those accounts as different administrative boundaries. And this is a place where AWS organizations can help with the overall account relationship, structure, and governance. But even if you're not using organizations yet, we still recommend a payer and linked account structure with that separation based on those administrative boundaries. All right, from account structure, we move on to some network design decisions. So in our use case, we said we had about 4,000 users. That's a minimum VPC CIDR block of a /20, so 4,096 addresses, or two /21s at 2048 addresses each. While that would be sufficient for current needs, if we want to allow for future growth, maybe start at a /19, so you start with a pool of 8,000 addresses, and then subdivide 2 /21s for WorkSpaces, 2 /22s for AppStream. That leaves you with a /21 left over. So Amazon WorkSpaces always requires 2 subnets in different availability zones. And now AppStream 2.0 will allow you to deploy in a single availability zone, but for better architectural principles, we would always recommend still go ahead and split those workloads across 2 subnets and different AZs. And then size your subnets to accommodate that target end state capacity. It's going to take some whiteboarding with your network engineering. If you have plenty of IP space available, maybe you start with a bigger block. If you grow beyond the boundaries of your original VPC, you might need to add a new range, and we do support adding additional CIDR blocks to VPCs. So now we've set up the account, we have our networking defined, we have your VPC and your subnets created. What you need to know about the network interfaces. So an instance in either service will have two network interfaces. For WorkSpaces, ETH0, actually for both services, ETH0 is the service interface. On WorkSpaces, PC over IP traffic runs over ETH0, runs over that service interface. All of the original session creation and then the session between the streaming gateway and the end user's actual device runs over that service interface. All user traffic runs over ETH1. So ETH1 gets an address from the subnets that we talked about in the prior slide. All user traffic runs through there, and you control how those AppStream instances or workspaces get access to the internet through ETH1. So whether you grant internet access through a NAT gateway, or if you're setting up a content filtering system, you can even route it back over your virtual gateway into your customer environment and run it out over content management systems that you may have in on-prem. You could also set up EC2 instances. We have some partner products in the marketplace, Sophos, Cisco, Palo Alto networks that do some content filtering. If you wanted to do content filtering, you can run that outbound interface through EC2 instances in your public subnet, route it that way. The key message here is whatever you do, it's totally up to you. All of that user traffic is in your VPC, controlled by the policies, security groups, and routing rules that you make. That user traffic, because it's in your VPC, can be routed to file servers, backend databases, licensing servers, and so on. You can reach peered VPCs. In the account slide, I had a shared services VPC in the middle. That was where our Active Directory environment, ADFS, multi-factor authentication, those types of common systems that would be needed by multiple other accounts would use. You can use VPC peering to get there. Again, it's standard VPC traffic. All right, so after talking about the account, the network, we move on to user access and directory integration. So for our example, we're going to assume a requirement for domain authentication for both WorkSpaces and AppStream. All workspaces are going to be domain joined. That's core part of the solution. Workspaces are joined to an Active Directory domain. AWS Directory Services is required to connect a user to their workspace. Under WorkSpaces, the directory service gives you a reg code. The directory service is how workspaces connect a user to their specific workspace. The reg code is the same for all users within a directory. AppStream, for domain joined fleets, the connection between a user and their fleet is created by the relay state. It's handled by the relay state passed via a SAML response. So you can use AppStream in either domain joined or standalone mode, but as I said, we're going to assume that we have a requirement for domain membership, and that's going to require that you use AD joined fleets integrating with SAML via your identity provider. You do not need AWS Directory Services for AppStream SAML integrations, but you will need a SAML endpoint and an identity provider. So Active Directory recommendations. I always say to extend your AD into AWS on EC2, and a big part of that is once, when we're talking about workspaces, once you've made that initial connection, all of the rest of the traffic between the workspace and the Active Directory environment is through standard AD communication. So you're actually going back potentially on-prem to talk to your AD controllers, all of your group policy replication, all of your file replication. Everything happens with that normal behavior of Active Directory sites and services. Use cross-account VPC peering for communications to a shared services VPC. And then define your VPCs in AD sites and services. I see a lot of people that will set up AD and then forget to go and modify that site and services piece. So the communication still kind of goes wherever it randomly feels like going. You want to make sure that you've actually defined the sites in AD sites and services so that your workspaces and your AppStream instances know how to respect the AD site. And then I recommend separating AD organizational units by service and region. So separate OUs for workspaces for AppStream, and then different regions. That allows you to just use AD group policy settings to apply different settings to both services or throughout any of the regions as your needs may vary. All right, let's see what that actually looks like. All right, so I'm going to start by connecting to a workspace. So this is an always-on workspace. The connection time is usually between 6 to 8 seconds to make that connection to an always-on workspace. If you're using hourly workspaces, if the session hasn't hibernated, it's the same connection speed. But if the system has gone to a hibernate mode, it takes about 1.5 to 2 minutes to make the connection. And what I wanted to show here, this is just a performance workspace, so it does not have a GPU enabled. I've got Blender installed here. Start to run Blender, and the first thing it says is, your system does not use 3D hardware acceleration. Gives a variety of reasons why this could be a problem: missing graphics driver installation, accessing Blender through a remote connection, or using Blender through a virtual machine. I am doing all of those things, so I've checked every box on why it could possibly fail. I'm using Okta's IWA agent to allow single sign-on with Windows authentication through a service running in my EC2 environment, so I didn't have to re-log on to the AppStream session here. I'll go later and show what that looks like if you're accessing from outside of a workspace or from a non-authenticated environment. But you can see here the AppStream console where I have Blender available in there as well. All right, when you're using domain-joined fleets, it will prompt for an Active Directory password at login. So even though I passed through the IDP without requiring authentication using single sign-on, once you're actually in session, this is a standard Windows desktop. You have to log on with the username and password. The SAML assertion is not sufficient, so we've got to see if I can remember my password while I'm on stage. All right, looks like I got it. Now, within my workspace, this is a domain-joined workspace, of course. They all are. I have an H drive mapped. You can see the files here. I've got a Blender directory with a source file, and then an output directory that is empty. So we're going to go into Blender. This is a domain-joined instance. I'm getting that same GPO that maps my user file. So when I go to open, we see the H drive here, same files that we just showed. Oops. So we're going to open the helicopter scene. Now this is a Graphics Pro instance that I'm running on. So I'm going to show you first here when we actually start this render. You can see after a couple of seconds here, it'll start giving you an estimate on the remaining time. Right now, it's estimating 5 minutes to complete this render job, which seems a little odd for a Graphics Pro instance. So I'm going to close that. Under User Preferences in Blender, you can specifically tell the system to use GPU acceleration. You can see here the Tesla M60 display is available in the device selection screen. We'll save that setting. And now when we re-render that scene, estimating 20 seconds. So the output file from this job is running to my H drive, so I can now move back to my workspace as soon as that's done. Actually, I closed it a little too early there. Here we are. The output results, I can now bring that into other applications that I might be running on my desktop. I can send those workflows off to wherever they need to go. My data, my usability is there, and I'm only paying for that higher cost graphics instance when I need to run actual graphics workloads versus assigning the user a full-time GPU workspace when really the majority of the work that they do is suitable for a standard or performance workspace environment. All right, another thing in the AppStream instance here, we're going to go back And again, I'm running this AppStream environment in a workspace, also from my, so it's a double virtualization environment that you're seeing up here, right? Because these environments exist in my VPC, the endpoints exist in my VPC, hopefully, let's see, I have a small VPN server that runs in my closet at home, if no one turned that off. Yes, all right. Good, my closet's still running. I'm using the connection to the printer here because Amazon doesn't host HP ColorJet printers in the cloud. It's just not something we've figured out yet. So it's very clear this is going back to something that you wouldn't have access to from the show network, from anywhere else. This is happening inside of my over my VPN connection back to my home. I can clearly see that my children have been printing minions. I'm out of yellow. Blue. So we'll have to work on that on the way home. So you have access to any of your local networks, anything that you've defined within those VPC routing tables. All right. The interfaces within AppStream, you can see the window selection here. We have some options to go in and see what your current performance looks like. There are channels for storage within AppStream. We create an X drive if you assign a user storage to your fleet, and we'll actually save files out to S3. But what I'm doing here with the domain joined instance, I'm just using my existing, already created Windows storage environment. All right, I'm going to end this session because I'm going to connect to it from outside. All right, I'm going to exit the workspace here. And we'll go to the console. So what does that all look like in the console? I'm not going to get into necessarily the VPC setup, the VPN connections, all the routing tables, and so on, but I'll focus predominantly on the workspaces and AppStream piece. Workspaces, here's my ReInvent workspace. You can expand details here and see the directory registration code. Workspace IP, this is the address, the 10.0.10.38 in this case, that is assigned to ETH1. So when I talked about these services having multiple interfaces, this is the one for this specific workspace. That's going to remain consistent for the life of that workspace. So until I do a rebuild or a terminate and then reassign a workspace, I'm going to keep that address out of the pool. So you can go into your EC2 console under Elastic Network Interfaces and search for that 10.0.10.38. And then you can add additional security groups, or if you need to do troubleshooting, you can open port 3389 to allow inbound remote access. All of those normal controls, you can still do that. You'll see those in the EC2 console, but you don't see the instances themselves because the instances run in a service account. All right, so that's workspaces. Not a whole lot to see on that side. Let's go into the AppStream console. AppStream, so you'll start in AppStream with images, and we're going to go into an image builder. I've got mine running here. Connecting to your image builder instance is a simple process, and I've had to spin some things up because a lot of these steps in image creation, in baking the AMI, and in the steps required for setting up the fleet, they're anywhere from 5 to 30 minutes, right? If you're creating a big image, it takes a while to create that AMI. So I'm pre-baking some of the pies here so we can show what that process looks like. We've already got the image builder up and running. You connect to it, you'll see that the initial connection looks a lot like connecting to the AppStream service itself, right? The difference is you now have a full Windows desktop as part of that image builder instance. To add an application to the instance, let's see, it's just a matter of finding your source file. So if you're on a domain joined instance, you can pull that from your internal software repository. If you're installing commercial off-the-shelf software, you can download that from your vendor's software. You could throw your install bits out on S3 and pull them down to the instance. The key is you just need to transfer them in somehow. So we're going to go ahead and run a Sublime Text setup here. All right. Now that we have the product installed in the system, you go into the Image Assistant. And it's a simple matter of adding the application and then finding where I put it. You can see here the Edit Application Settings field is very similar to what you'd have with a standard Windows shortcut. You can provide launch parameters, you can provide a working directory, you can change the icon if you want to have a different image for your users, if you're doing things for internal use. I like to take out the underscore and the display name, save, and now you'll see that that product show up in the list along with the other items that were out there. So the next step in creating an image is to run through a test. You'll switch to the local test user. You can also join in as a domain user if you wanted to test as a domain user in this state. That'll push down the group policy settings that come to that user. You can determine at the point where you're provisioning an image builder instance whether or not you want that image builder to be domain joined or if you just want your fleet to be domain joined. So now we're in the interface as a non-administrative user. You'll run the image assistant again. You'll notice there's only the one tab for testing applications. You can click to start your applications, make sure that they function. We just put Sublime in there. Let's see. There we are. It runs. We're good. And then after that, you switch back to the admin instance. All right. You'll move on to the next phase, which is image optimization. So what this is doing, it will run through every application that you've added to your stack, starts the application up, monitors the processes, monitors the files that are in use, and when you, in the future, provision application streaming instances in your fleet, we'll use that information to kind of pre-warm the volume that underlies the instance so that your applications can start a little bit faster. So allow everything to start. I don't know why I have calculator in there. All right, a brief run here while it finishes. Then you give your image a name, a review, and then when I disconnect, it would start to bake an image. Now I'm not going to do that step because it takes a while and you won't see the outcome from that step. So we're going to disconnect from the admin image here. All right, and back to the console. So now that you've created an image, it will show up in your image registry. You can filter on keywords. So for reInvent, here we see the images that I've been creating as I move through this process. In the image registry, you can the notes that you create within the image builder. It'll show you the executables that are installed, the applications that are available on this tab. And then some basics around what you used, whether it was domain joined or what for the detail screen. From there, from creating an image, you move to defining a fleet. Now, a fleet is the group of streaming instances on which your applications run. And this is another place where you can decide what your hardware configuration looks like for those systems. In this case, we're running with the fleet the reInvent demo. You can see information about the VPC where those systems are deployed, the subnets, the security group that's going to be applied by default to all of those instances. So again, if you need to grant access to other resources in your environment and you want to do it fleet-wide, you can go in here to the security group that's defined at this stage and make changes to those security group rules. You can see I'm using Graphics Pro 4XLs for the instance sizes. And then you also have a directory organizational unit where those systems will actually be deployed in your AD environment. Your directory config is further down on the AppStream page. It's a pretty basic configuration. You're giving it a service account that has rights to a particular OU that you'll define down here. The service account needs the ability to read computer account information and join accounts to your domain. All right, so within the fleet, your fleet usage shows up in the policy or the tab at the bottom here. This information is also captured in CloudWatch. So if we go over to CloudWatch, we should see something very similar to the graph that we have at the fleet usage at the bottom. So you can export that data over for the life cycle of what we store for CloudWatch data. If you wanted to do more analytics around the average performance or user connection times for your fleet, CloudWatch is where you're going to pull all of that data. Scaling policies are where you actually determine the capacity rules for your fleet, and you'll also notice the corresponding alarms for your scaling policies that show up under your CloudWatch alarms. So I have a scale out alarm, and there'll be a scale in alarm that can trigger when capacity utilization falls below a particular threshold. So what I have set here is if my capacity utilization of the entire fleet exceeds 75%, I add 2 instances. That's going to start spinning those instances up in the background. If a user tries to connect at a point where all of the instances in a fleet are already in use, but you have capacity available and you're in the process of spinning those up, they'll get a message that says, please try to connect again in 3 to 5 minutes. If user waits 7 minutes, the additional capacity for the fleet will be up and available, and they can just connect directly. So that takes a little bit of analysis, right? You're not going to get that right probably on the very first go. You don't know when your users are showing up or how frequently they're connecting to those instances. You're going to want to do a little bit of monitoring of that environment to see what those usage patterns are, and then adjust your fleet scaling policies in accordance with that. The scale in policies look for capacity utilization falling below a threshold and then start to remove instances from the fleet. So this is a mechanism that you can use to help with those cost controls, right? You want to run the right number of fleet instances to support the user connectivity that you have at any given point in time. And this is a way to kind of build some of that in there. You can also use Lambda jobs to change these scaling policies, and that's a really key element, because that means you can set time-based Lambda functions that will automatically add more baseline instances to your fleet at the time when your users are coming into the office. Or over the weekends, it'll minimize your fleet so that you're running fewer concurrent instances, but perhaps still have some connectivity out there and available for those people like us that work on weekends. All right, stacks are how you actually grant your users access to the systems. So in this case, we're using SAML integrated stacks. So I'm going through Okta for my SAML assertions. But you can see here the details for the stack. We show that it's active. You can also define whether or not you're going to enable home folders. This is the native home folders to AppStream, not the mapped drives that I'm doing with the domain joined fleet. And within any of these systems, so fleets, you can start or stop individual fleets. I did want to also show you on the on a stopped fleet, you can go in and edit the instance types. Now you can't change between graphics instance types and other instance types. You can change within different sizes of a particular graphics family, but there are custom drivers required, graphics drivers required for those GPU-enabled instance types. So for those, you're only going to be able to change instance sizes within the family of the same type of graphics card. For the other instance types, however, we do have the flexibility to change to standard compute or memory enabled instances through any of the different sizes. And it's simply a matter of you resize your fleet by selecting a different option in the dropdown here and then restarting your fleet. This is also where you define the subnets that are used by the service, the security group that are applied by default, and whether or not you want to have a directory config for those fleets. All right. Changing the image. So you can see here I've got a couple of different places where I generated a couple of different images for today. Now it's going to take a little bit of time to spin down and spin up the fleet. You can change the fleet that's associated with a stack to do an instant changeover, or you can change the images that underlie your fleet. Here under Edit, you can simply select a different image type, and the AppStream service will start to retire your old instances and bring up the new ones with the new image. So as you're adding applications or as you're applying security patches to the underlying system, going into the fleet edit and changing to the new image is the quickest way to deploy that update to all of your users. But almost started that, but I did want to show what the login looks like if you're not on a domain integrated system. So I'm outside of the workspace environment here. I'm on a browser. I'm logging into my identity provider page. And we see the AppStream that I've published to this user's account. And after this, most of the interactions are exactly as they were when I was in the workspace, except I shut it down just a second ago. So, yeah, that's the difference between being in a domain-joined environment or connecting from home. If you're on that domain-joined workspace, you can take advantage of that single sign-on pass-through. I'm using the Okta IWA application to do that. If you're using something like ADFS for your SAML provider, then you've got to enable domain integrated authentication and single sign-on for that to work. All right. All right, so the products are available in AWS accounts now. So AppStream was released a year ago. WorkSpaces is about 3 years old. We do have a free tier available for WorkSpaces. That'll allow you to run 2 standard bundle workspaces for 40 hours a month up to 2 calendar months. We do have the Windows 7 and the Windows 10 experience. That includes WorkDocs with 50 gig of storage in the free tier. And you'll notice the word experience there. So a workspace actually runs a server operating system. Windows 7 is Windows Server 2008 R2 with the Windows 7 Experience Pack. And Windows 10 is Windows Server 2016 with the Windows 10 Desktop Experience Pack. AppStream 2.0, you saw what it takes to start an image builder. It's all an in-browser process. There's no software to download, no clients that you need to pull in, no special SDKs that have to be installed. You can try some sample applications. We have some sample images out there that have a few applications built into them. Or you can upload your own files, test a workflow, save your work, print, test what different group policy settings do. Now, I have this related sessions slide, but these all happened on Monday, Tuesday, and Wednesday. So keep an eye out for these. They are. Oops, looks like I also have an auto advance on there. We will be uploading all of those sessions to YouTube, so you'll be able to go out there and see the sessions that have already happened. But yeah, these are the ones that are kind of related to this session. So thank you very much. Please remember to complete your evaluations, and I'm going to hang out for another 10 or 12 minutes to answer questions up here.